The learning objectives of this section are to give the trainee knowledge about the various radar controls, their functions and their limitations, how to set up and maintain various radar presentation modes, understanding their main advantages and disadvantages. It cannot be stressed enough the importance of setting up and maintaining an optimal radar picture at all times, during the various operations and weather conditions. Several court decisions have confirmed the navigator's responsibility to utilise the radar to its maximum performance at all times. The following table gives a start-up sequence and describes the most common functions and controls found on today's marine radar. Press the buttons in the same sequence as given in the table below and watch carefully what happens on the radar display. All navigators, as soon as possible, should familiarise themselves with their radar and all the radar controls. The navigator should use the radar in conditions of good visibility in order to familiarise himself with the performance of the radar and to actually see the effect of the various functions and features provided. This will hopefully give him confidence in the radar, and this can prove useful during navigation and traffic surveillance during periods with reduced visibility. Power on/off. This is the main power switch for the radar and is normally connected to a timing device, which automatically provides the warm-up time necessary prior to operation. Radar standby. To stop transmission and high tension supply while keeping the filaments warm, thus having the radar ready for use within seconds. Scanner on/off. Starts and stops the scanner. Brilliance +/-. The brilliance or video control adjusts the signal intensity on the PPI. Correct the adjustment when the sweep is barely visible on the screen. Gain +/-. The gain control can be compared with the volume control on a radio. Correct the gain setting when the noise is barely visible on the screen. Tuning +/-. This control can be compared to the tuning control on a radio. For optimal receiver sensitivity, the transmitter must be tuned as accurately as possible. On some radars, this control is automatic. Focus +/-. This control determines the sharpness and clarity of the radar picture. Focus setting is easy, with the range rings on. On some radars, this control is automatic. Anti-clutter C +/-. Whenever excessive C echoes are presented, anti-clutter C should be applied, so that only a few C echoes remain on the radar screen. This function is active only to a distance of 4 to 5 nautical miles. Do not operate the radar with a C clutter in a fixed position. Anti-clutter rain +/-. The purpose of this function is to reduce echoes from rain. The function activates a differentiator which automatically breaks up large echoes to enable visibility of other objects. Do not operate the radar with a fixed anti-clutter rain setting. Range rings +/-. These control switches adjust the fixed range ring's intensity. The intensity of the rings should be kept to a minimum at all times. If not used, keep it switched off. EBL intensity, plus minus. The variable electronic bearing line is utilised to obtain bearing information, mainly used when one's own ship is not located in the centre of the display. VRM intensity, plus minus. The variable range marker, or ring, is used to obtain the distance from the sweep centre to any position on the display. Gyro on-off. Connect or disconnect the gyro compass to the radar. Panel illumination. Used together with a rollerball to regulate the background illumination of the push buttons. Illumination of the push buttons should be kept as low as possible at all times, as excessive illumination may destroy the contrast on the radar picture, create annoying reflections and destroy night vision. Log on-off. Connect or disconnect the log to the radar. Cursor brightness. Used together with the rollerball to regulate the illumination of the cursor on the display. Manual speed. Used together with the rollerball to increase or decrease the required value for manual speed input to the radar. AN brilliance. Used together with the rollerball to regulate the illumination of the AN displayed data. Manual drift direction. Used together with the rollerball to specify estimated drift direction. Fixed range rings. Used together with the rollerball to adjust the intensity of the fixed range rings. Manual drift speed. Used together with the rollerball to specify estimated drift magnitude. Bearing scale. Used together with the rollerball to adjust the intensity of the electronic bearing scale. Course up. When lit, this button indicates that a stabilised course up presentation is selected. True motion. When lit, this button indicates that a true motion presentation is selected. Head up. When lit, this button indicates that an unstabilised presentation is selected. Relative motion. When lit, this button indicates that a relative motion presentation is selected. North up. When lit, this button indicates that a stabilised north up presentation is selected. Relative motion. When lit, this button indicates that a relative motion presentation is selected. Range plus. Every time this button is pressed, the range is increased by 1 step. This switch also controls the selection of pulse length, as all ranges from 6 nautical miles and below are given a short pulse, while all ranges above 6 nautical miles receive long pulse settings. Range minus. Every time this button is pressed, the range is decreased by 1 step. This switch also controls the selection of pulse length, as all ranges from 6 nautical miles and below are given a short pulse, while all ranges above 6 nautical miles receive long pulse settings. Afterglow plus. Every time this button is pressed, the afterglow time is increased by 1 step. Set center. Pressing this button will place the sweep center in the position of the marker. Reset center. Pressing this button will reset the sweep center to the default position. Heading line suppress. This function is used to remove the heading line for short periods, to see if weak echoes are hidden. The switch is spring-loaded, so it cannot be left in the off position. VRM control. The VRM control is used to VRM control. The VRM control is used to position the variable range marker into the required range. EBL control. Used to position the electronic bearing line into required position. Many factors may influence a navigator's choice of radar presentation. Availability of equipment and own experience will naturally be deciding factors. But it is important the navigator is aware that he is not completely free in his selection of radar presentations. The basic rules are, regardless of the quality of the ship's radar equipment, that it should be utilised to its maximum capability. This means that, if the ship's equipment is of the optimal modern kind, with all the various finesses, the operator is obliged to utilise it to its maximum capability, regardless of whether he has got the proper training or not. There have been many court decisions supporting this practice. Here is an example. A navigator on a ship equipped with true motion radar, operating in an area with dense traffic, is obliged to utilise true motion radar presentation in order to avoid additional problems in a possible collision case. The reason for this is that the true motion presentation is considered to be and is the best choice under such conditions. Most navigators who use their equipment correctly will soon obtain the needed experience to choose the presentation that provides the simplest and most accurate information at any time. The range accuracy of radar is generally high. Range can be measured on radar with reference to fixed range rings, equally spaced around own ship's position on the radar screen. For more accurate measurement of range, most modern radars provide a variable range ring which can be positioned in any range on the screen. The variable range ring should regularly be checked for accuracy against the fixed range rings, which are normally more stable. With a variable range ring, more accurate range measurements can be taken. Fixed range rings can be used when the need for high accuracy is not important. The bearing accuracy of marine radars are normally not so high. The main reason for this is that the bearing accuracy is governed by so many factors related to the inherent characteristics of the radar. Here are a few important error sources. Beam with distortion, which can be partly eliminated by reduction in gain. Heading marker error, which can be determined by various methods. Centering error, which can easily be corrected. Error due to yawing of own ship. Error due to parallax when viewing the display. Always read and follow the radar manufacturer recommendations for use and maintenance of the radar equipment. This will save you time and money and ensure proper use of the equipment. Always remember to adjust the centres correctly. Apply the heading marker error if there is one. Check the compass readings if the display is unstabilised. Reduce the gain to reduce the beam width distortion. View cursor and bearing scale from the correct position. Always use true course as input to a stabilised radar display.